Okay, let's go. First things first. Everything. When you draw them, you've seen these diagrams hundreds of times, correct?
Yes.
Okay, so what are these diagrams telling you? These diagrams are telling you that matter, whatever it is, whether it is solid, liquid or gas, are made out of particles, right?
Yes.
So these particles we have, how many types?
3.
Okay, so we have atoms, okay, which basically means that they are sitting next to each other, but there's no chemical bond. They have no
Chemical.
okay, or they're sitting like this. So they can be solid, liquid or gas. Okay, so normally anything that's atomic, okay, so we say these are atomic, will either be our metals or our noble gas. So in the exam, they can give you names. They'll give you iron, oxygen, okay, they'll give you carbon, right? They'll give you neon, they'll give you carbon dioxide, they'll give you ammonia, and then they're going to be asking you what are the particles inside them. So atoms, metals and noble gas. Okay, so our molecules. Now molecules are a bit tricky, right? Because molecules have to be non-metals combining. So mainly they are non-metals. Try to remember that. Yeah, because we've got like O2, H2, yeah, N2. So these are non-metal elements. And you have compounds. Your compounds are things like CO2, SO2, NH3. Is there any one of these you don't know? Carbon?
Carbon dioxide, sulfur dioxide, and ammonia.
Okay, so like those are molecules. So they tend to be non-metal elements. This is the element part. Non-metal compounds, meaning that inside here the atoms that make up the compound are non-metallic. Get that?
Yes.
Okay, then the last one is ionic. Ionic means it's got to be, so ions, it's got to be a metal combining with a non-metal, because there has to be transfer of electrons. So you've got to have a cation, which will be your metal, and your anion, which will be the non-metal, except for ammonium. Try to remember ammonium is a positive. Okay?
Yes.
So you're going to get names like copper 2, sulfate, magnesium, oxide, like that. And then you got to start lah. So they can give you this in the paper and ask you, they'll give you the names at the top.
Right.
Okay, so magnesium oxide contains what particles?
Maybe an oxygen.
Yeah, what particles, not what elements.
Oh,
It's a metal and a non-metal.
So it's an ion.
So it contains ions. Okay, so this one ions, this one metal and
Non-metal.
so
It contains ion.
contains ions. Iron,
Is no. It's a metal, so that means it's an atom.
so it contains atoms. Oxygen,
Contains molecules.
because it's a non-metal, diatomic. Okay, carbon,
It's a metal, so
no, carbon is not a metal, young man. Carbon is a non-metal.
non-metal.
But it's weird because these are your giant molecule structures.
Right.
So they are really weird. They are molecular, so they should come under molecules, but they're very close to atomic.
Okay.
Okay, neon?
Molecules.
No, noble gas. Don't make mistakes
Right.
like this, Anil. These are lost marks. Take your time. You got to understand all noble gases don't combine with anybody because they have a full valence shell. They're already stable, unreactive, correct. So you got to remember that about your non-metals, right? Carbon dioxide, Slowly, slowly. You're rushing, you're jumping into it, and you don't know what's inside the water. Yeah, if there's a sharp object in the water, you're going to jump in and it's going to impale you. You're going to die, boy. Don't die. Slow and steady. Element, compound.
Compound.
Contains metal and non-metal.
No.
Contains non-metals.
And non-metals, yes.
So,
It is a molecule.
like that. You see, think about it. This one.
Again.
Element, compound.
Non-metals.
Element or compound?
Compound.
Okay. The constituent elements?
Non-metals.
Non-metals.
So it's a molecule.
Like that. Take your time, Anil. Don't just look at something and go like blur. Yeah, we don't need to blur. You got 1 hour, 15 minutes to get everything correct. Right? And you can get everything correct. As long as you do it slow and steady. So now you understand this particle part?
Yes.
Alright, well the next part is to know about your solids, liquids and gases in terms of your kinetic theory. Now, it's these diagrams. The diagrams tell you everything. The diagrams tell you the arrangement. Okay, these are
Orderly.
closely packed. First word is the closely packing.
Right.
It's the distance between the atoms inside there, or the molecules inside there. So the first thing is the distances. So we use the word closely packed, or we use far apart. This is closely packed. Liquids are closely packed. Gases far apart. Alright. Now the next thing we want is how they are arranged. So arrangement part 2 is the how they are arranged. We put there how. These are orderly. These they are not orderly.
Not orderly.
And these random. They are far apart. Like that. That's arrangement. The distances and how they are arranged. So you can see the differences already.
Yeah.
Right? Then the next we want to know about the kinetic energy inside there. That is to do with movement. So you're talking about how these particles are moving. So in a solid they are
Vibrating about a fixed position.
about a fixed position, which means is their movement large or small?
Small.
So their kinetic energy
Is low.
it's low, correct. So low, like that. Then you go here. These slip and slide past each other. So easy to remember. Slip and slide past each other, right? So their kinetic energy we'll say is moderate.
Moderate.
Okay, so for liquids it's mod, and then for gases, we know we always draw gases with these really long arrows on them, which means they're moving at
High speeds.
high speeds and random.
Random.
Like that. So that's what they want to know. They also want to know the other stuff like shape. This one, because they're all fixed, the shape is fixed. These take the shape of the container. They want to know about compressibility.
Right.
To compress something, we're looking at distance. This is the only one that's far apart. These two are closely packed, so they cannot be compressed. You get the idea?
Yeah.
Like that. So, understand what they're telling you. And then, we want to know a bit more about gas. Really, when we say we want to know a bit more about gas, what we are saying is, we need some proof that particles are in constant motion. So, this extra bit about gas is your particles in constant motion. Now you need to show this. Now to show that particles are in constant motion, we use diffusion experiments. Where the most simple one is you got the two gas jars like this. You put the bromine gas or whatever colored gas at the bottom. You pull the card out and slowly the color will move up against gravity. And then they want to know why it's slow. Why a particle here will move up like this and then suddenly move this way. Because what's happening?
It's colliding.
That's right. It's random Why? Because there are collisions. Collisions with who? With bromine molecules
And
and air particles that we cannot see. Like that. Right?
Yeah.
So that's why the movement is this random movement. So slowly it will spread out from higher concentration to lower concentration. So it's a very slow process. Yeah?
Yeah.
And then we also have the mass experiment. Now, the mass experiment is where you're putting two gases in a tube and you want to see their rate of diffusion based on mass. But we need to be able to see them because the gases are both invisible. So here we use ammonia, and here we're using
wool soaked in hydrochloric acid.
conc hydrochloric acid normally. And when this one diffuses faster, this one diffuses slower, we get a white vapor here. It should be about 2/3 of the way, white vape, and it should be, like I said, about 2/3 of the way down the tube.
So closer towards the hydrochloric acid
Yes.
side.
Okay, so about 2/3 here, 1/3 here. And what is the white vapor?
Hydrogen
Ammonia plus this. What are you going to get?
ammonium chloride.
You're getting ammonium chloride like that. That is the white vapor. And what do you realize? That when the mass increases, rate of diffusion decreases. Okay? Or the opposite, the lesser the mass of the molecule, the faster its rate of diffusion. Okay? And then you have your one, the one that you mentioned, which is Brownian motion. Okay? And what are the Brownian motion? What is it showing you?
The random movement of
Okay, the random movement
of particles
due to collision. Okay, and normally what do we use? We use smoke. And what's bombarding the smoke particles?
The air particles.
Okay, like that. All good?
Yeah.
So you see, now that's chapter 1. Chapter 1 is not complicated. Yeah, but you got to know these particles. And you got to know examples of these particles. You cannot just say atom, molecule, ion, but don't know what are atoms, molecules, ions. It is the basis. You know, whenever we look at something, we got to know what the particles are made out of. I mean, if we don't know what the particles are made out of, that's like eating food and you don't know what's inside the dish that you're eating. You know, that's like tasting a meat and you don't know whether it's chicken, lamb, or anything. You got to know what it is. You understand? So when they give you aluminium, you got to go. Aluminium is an element. It is metal. It contains atoms. The structure will be atomic. They give you something like nitrogen. You go nitrogen. It's an element, but it's a non-metal, so it should be a molecule. Its structure will be molecular. You know? They give you magnesium oxide. You go, okay, this is a compound, there's a metal, there is a non-metal there. That means it must contain ions. The structure will be an ionic lattice. That's right. So you got to know all of this. And the one to be careful about is the noble gas. Because remember, noble gases are monoatomic. Right? Because they have a full valence shell and they are unreactive. So you got to know, even though you're saying non-metal, you just got to be a bit careful about noble gases. Because they don't behave like other gases. Get everything?
Yeah.
Alright. Okay. So, that's chapter 1. Okay? Chill over chapter 1. Go through your chapter 1 now with your book. With your finger, you're going over the chapter. You're going over the chapter like this. You're reading at full speed. Take about 4-5 minutes, 10 minutes. Get to the end of the chapter. Right? Pen in hand or pencil in hand. The minute you read something and you understand it, you tick it at the side. So once you tick it. Then after 10 minutes, we go through the chapter. Anything not ticked, we go back over it. Because once we're done with the chapter, it's done. Then we should be practicing questions after that. Okay? Speed reading. Anil, speed reading. Take your time.